Homework 2.3, Linear Functions and Slopes, Video 3. Homework due Friday, May 22nd, 2020 at 11:59 p.m. Now that we've talked about slope and how to calculate it and how to interpret when slope is positive, negative, zero, or undefined, let's talk about equations of lines. And I'm going to sneak in linear functions into this particular video. Watch out for it. There are a lot of variations, excuse me. There are a lot of variations on equations of lines. And most of those variations, not all of them, but most of them hinge on information that you may know in advance. Three forms of the equation of a line that we'll be looking at are called point-slope form, which I will abbreviate PSF, slope-intercept form, which you may recall, and I will abbreviate SIF, and general form, which I will abbreviate GF. Of the three, general form is my least favorite. I'll explain why when we get to it. The point-slope form, as its name implies, is the form of the equation of a line that you can build if you have a point on the line and the line's slope. So, if a line contains the point x1 comma y1, so it's a specific point generically, and has a slope of m, then the point-slope form of the line is y minus y1 equals m, open parentheses, x minus x1. That is called point-slope form. It's like a recipe for a line that requires two ingredients, an ordered pair and a slope. In the next video, we'll do some examples of building equations of lines, but I want to give you the recipe first. Now, before we get to slope-intercept form, I'm going to kind of briefly explain where point-slope form comes from. Point-slope form is just the formula for slope, but without the twos and with the fractions cleared out. Allow me to elaborate. The formula for slope is m equals y2 minus y1 over x2 minus x1. To get point-slope form from this, you could start by multiplying both sides by the denominator. Let me do something real quick. I'm going to write the formula again, but I'm going to put the m on the right side. It's the same formula, but the reason I'm doing it is just, it'll be easier to write what I'm going to write next. But if we start with the equation, or the formula for slope, and we multiply both sides by the denominator, so x2 minus x1, then that gives us enough ammunition to cancel the fractions denominator, leaving us y2 minus y1 equals m times x2 minus x1. And then if we make the second point generic, instead of specific by removing its subscripts, but we leave the subscripts on the x1 and the y1 to mean a specific point, we just don't know what it is, then we get point-slope form. So that's all point-slope form is. It's a cleaned up version of the slope formula without the twos. Now, a lot of you may remember slope-intercept form. I know this because when I teach this as a lecture class, and we start talking about the slope, the first thing I ask people is, tell me anything you remember about slope. And inevitably, somebody tells me y equals mx plus b. But let me be a little bit more specific. Sorry, folks. Slope-intercept form is a form that you can build if you know the line's slope, but you also know the line's y-intercept. I wish it said slope y-intercept form because a line can have an x-intercept also, but the intercept in slope-intercept form is referring to the y-intercept. So it goes something like this. If a line has a slope of m and a y-intercept of b, and I know why they use the letter b, but that basically that's representing where the line crosses the y-axis, comma, then slope-intercept form is y equals mx plus b. Why does it get to be y equals mx plus b? Well, actually, it's just a derivative of the point-slope form. Because think about it, for point-slope form, you need a point and the slope. Well, we're calling the slope m, but if we say the y-intercept is b, that's a number, not an ordered pair, but we can make it an ordered pair. If we're saying that our line crosses the y-axis at b, then this point is 0, comma b, because it's on the y-axis. If your x isn't 0, you moved left or right, and you're no longer on the y-axis. So you can actually describe the y-intercept as an ordered pair whose x-coordinate is 0, or just as a single value. But with this point and this slope, if we took point-slope form, y minus y1 equals m times x minus x1, but used this specific point, meaning we're going to use 0 for x1 and b for y1, then this will clean up really nicely. Because first off, subtracting 0 from something doesn't change its value, so this parenthesis is just equal to x, and we no longer need the parentheses. And then if we add the b to the other side, we get slope-intercept form. So it really is just a very specific case of point-slope form, using the point of the form 0, comma b, and it cleans up into y equals mx plus b. It's at this point where I want to introduce to you what a linear function is. If you recall that a function takes in an x value and returns a y value, in any equation ever, you can replace y with f of x. So we could equivalently say, instead of y equals mx plus b, we could say f of x equals mx plus b. And this is what's known as a linear function. It's basically slope-intercept form, but in function notation. So any function that has that form, or can be simplified into that form, is called a linear function. Now, what's general form? In a word, stupid. Wait, what? The reason I don't like general form is that its equation contains no immediate information. This does, here's the slope, here's the coordinates of a point. This does, here's the slope, here's the y-intercept. But the purpose of general form is to look pretty. Other than that, it's not worth much. It doesn't do much. It just sits around and looks pretty. I like to call it Kardashian form, but some people don't think that's funny. Because its only purpose is to look pretty, but other than that, it doesn't do much. Excuse me. Oh, great, it's going on YouTube. I wonder if that's slanderous. Ah, well, nobody's going to watch this except my Maymester students. Or I'd be surprised. Anyway, so general form doesn't contain any specific information. It just looks a certain way. General form is capital A times x plus capital B times y plus c is equal to 0. So in other words, everything on the left and 0 on the right. But wait, there's more. In order to look pretty, where the first coefficient, which is a, is positive, and you can always make it positive because if it's negative, you can just move everything to the other side, everything would change signs, and it would end up positive anyway. And there are no fractions. Well, let me be more specific. And A, B, and C are integers. Now, there are some equations that you cannot get into this form. For example, if A, B, or C was pi or the square root of 2, we couldn't magically turn them into integers, but if they're fractions, you can multiply by a good enough denominator to kill all the fractions. So general form's purpose is to look pretty. Everything on one side, don't start with a negative, and by the way, no fractions, please. So in some problems we'll start with general form and some will end with general form, but its only purpose is to look pretty. But the other two forms contain information. Alright, so those are the three types of equations of lines that we're going to run into. Again, slope-intercept form, if written in function notation, is the definition of a linear function. In the next video, we'll take a look at some examples where we make the equation of a line. And by the way, I meant to take this down before this video. Questions 1 through 5 are about calculating slope. They are not about point slope form, slope-intercept, or general form. But in your homework, questions 6 through 10 are. That'll still be up there in the next video because we're not done talking about point slope form, slope-intercept form, or general form.